Before we begin, I'd just like to say, like, hey, I'm the first time here in Russia. It's a pretty huge and influential country. Like, it's we're still like technically right in Moscow, right? Like, since like most people around this area would say, like, where do you live in Moscow? And it took us like 2 hours to get here. So, oh my God, this is a huge country. Yeah, when I grew up, I had a lot of influence from like Russian books and, you know, like cartoons, you know, like about like this wolf and the rabbit and whatnot. So like I watched a lot of those things. I don't know if you recognize those books, but like I had like those 3 books about space and would just like read through them. Like only one was translated to Polish, so I could actually read it. The other ones I just, you know, like followed the spaceships and, you know, the face of Valentina and Yuri, you know, like it was pretty amazing. And like back then I was like, oh my God, like, you know, the first country to like put something in space with the Sputnik, and then like the dog and Yuri Gagarin, like, you know, I wanted to be a Yuri Gagarin to do something to like that nobody else did, and like space was just like, oh my God, I really, really, really wanted to achieve something that grandiose. Like obviously that never happened, but you know, kids can dream, right? On that particular book, one of those, I found this like quote, and I'm like, Dad, what does it say? I don't speak Russian. And he said like, oh, it's a quote from Gagarin that just says that orbiting Earth and the spaceship, I saw how beautiful the planet is, and you know, like people, we should preserve and increase this beauty and not destroy it, you know. And somehow, these days, I feel like we're not doing a great job at this. And specifically, like for 3 years and 4 months now, there's this conflict that killed already 8,000 people, including Russians. And I'm very sad about this. I have friends from there that had to move either to like Vancouver or to Poland or to Lviv, you know. It is very heartbreaking to me. And I just keep thinking when I see this that, hey, come on, like, war is stupid. Space is wonderful. We should have like more Gagarins and more like Valentinas and just like send them where nobody's been before. So like, seriously, this is just my message to you today that like I think you're gonna sort of resonate with. I hope so, because this is what I would like to do. Like humanity can actually be great, like if we all do this together. But that's very philosophical of me. Let's just focus on what we're gonna talk about today. So, gradual typing for production applications. A little more boring, I guess, right? Less contentious. I'm Łukasz, Langa. I'm from the internet. You can find me in all sorts of places online. And here for the next 2 days, I'm happy to talk about anything, Facebook, you know, as analog synthesizers, whatever you want. Like, pretty much, I'm here for you. I don't speak Russian, though. I'm sorry. I never sort of had the opportunity to learn. Today, we're going to talk about typing. If you haven't used typing before, don't worry. Like I'm gonna do like an intro, like, hey, how does that thing actually work? This is gonna be like 1/3 of the talk, roughly. Then we're gonna actually think about like, hey, if you have already a gigantic application of like 1 million lines of code, and you're saying, I would like to use those type annotations, how do you start and not get insane? So that's going to be the second part. And the third part is most interesting if you already tried to do anything with types. If not, like you're just going to look at it and, you know, maybe it's going to be useful for you, maybe not. But I hope that whenever you actually come back to the talk, when you actually try to use it yourself, like these are going to be the things that are actually going to be the most useful, because these are the things that I tripped myself over when I actually started productionizing typing at Instagram. So first of all, this is very controversial. Suddenly we're adding static typing to Python, you know, like why would we even want to do this? Is this a good idea? Is this a bad idea? Like why would any core developer of Python with ducks and everything like want to make it more like Java, or maybe even, you know, some other language? Like why would you do that? Well, an example that like we devs of PEP 484 and whatnot sort of give very often is this, where like, what does this code actually do? Like you can see it, like it totally shows you like, oh yeah, it's a valid code, you can read it, you can say the words, but what actually is items? What is it? Is it a string? Is it a list of strings? Is it a list of IDs like in ints, or maybe it's like a list of some objects you don't really know. Oh, but you can infer, right? Like we're saying that each item has some like children field, so it cannot be a string or whatnot. But is children always set? Is this code buggy, or is it okay, right? So you have to read code, right? You have to go through the cyclomatic complexity to find, you know, all those cases where like, are we safe? Is there an error or not? And most importantly, like, what does the process do? It's a generic, stupid name. Obviously, nobody would add their name their methods like this. And it turns out everybody does all the time, right? You have validate methods, you have process methods, you can save methods, whatever. And then you try to grep for it on your big code base, and you find that there's 200 process methods there. So good luck, right? Like, this is the problem that we are trying to solve. First and foremost, and this is the most important feature of typing, we are trying to help readers of your code understand the code at hand. This is important for them to be able to like sort of find themselves inside the code base. This is important when you are onboarding more people. Your team is growing and new people are coming and they're saying, oh my God, this code is terrible. I mean, I can read it, but I'm super afraid of touching anything there. So actual type annotations sort of give you contracts. They explain how the code should be used, right? So this is one thing, but it also makes code review easier, right? Like you should have mandatory code review, and if you do, like people are gonna look at code and sort of trust you as a developer and like stamp it if it reads well. But sometimes it reads well, but actually doesn't do quite what we wanted. It was just like a reasonable idea at the time. So it totally helps with code review and makes debugging quicker, right? If you actually automate some of the things that you can do with typing. So you can also validate assumptions that programmers make, right? So if you write a new diff, you publish a pull request on GitHub or whatnot, like people can see what you thought you were doing, like your signature of your function sort of says what your assumption was. And there's less room for mistakes, right? And more space left in your brain to actually do like application logic. You don't have to like think of is instances all the time and worry about like, what if this thing is none and like everything goes to hell? Like you don't have to think that way. So it can find existing bugs and prevent future ones. That's the thing. How does this thing look like? Fortunately, the syntax isn't terrible if you're on Python 3. A normal function that reads perfectly fine, you know, for you gets just annotated by T, which is an argument type, and by R, which is a return type. Well, and people very often ask me, like, hey, like, why wouldn't you use docstrings, right? Like, we already had some syntax for docstrings, like that was enforced by Sphinx or other, you know, documentation generators. So why not this? Well, it turns out, like, this documentation is very often outdated and sort of not really parsable. It sort of looks like it's parsable to a human, but very often like people just do things that are wrong and make the docstring no longer easy for machines to read. So yeah, like docstrings, not really. Why not asserts? Well, asserts that you actually execute with your code have trouble, right? Because they are, first of all, overly restrictive. Then you are actually breaking your duck typing, and that's not really great. And are not free, right? You're paying for the performance of it. So yeah, this is why we don't have this. Like those type annotations get preserved at runtime, so you can get them if you really need to, like, you know, do some runtime form of type checking. But essentially, they are meant to be a static tool that you just sort of run next to your program, like without running it in production. Is this all Pythonic, right? That's like a question that, you know, like, or maybe like an accusation that I get. This is not Pythonic. What are you doing? Like, well, type annotations provide information that is essentially documentation. You should write it already, right? And for how your unit of code should be used, right? And programmers should provide type hints for public APIs. It's just good form then. Like if you don't do it like this, maybe you write something in Sphinx, you know, like add your APIs there on documentation. Maybe you just have a README on your GitHub repo. That's also fine. But the point is, if you are treating your job like seriously, you are already doing this. So this only formalizes where we would like this information to be put. It doesn't really say that you should do it when you didn't. Then maybe you should open a bakery because you're not responsible. You should document your code, right? So the kind of information that type hints gives you was always there, right? That's basically the point. So adding to that, that explicit is better than implicit, come on, this is Pythonic, right? Like, I hope I convinced you. So what is T? T can be any built-in type. It can be any class that you create yourself. And a bit of other things, we're going to talk about this later. Return types, same thing. A special thing that is useful for a return type is none. Well, technically none is not a type, right? But like, forget about like nobody wants to import non-type from types to just write non-type every time. So you can just write none, everybody understands what it means. It means you don't really want to return anything from this function, you return none, right? It's like a void function in C. All right, so let me give you an actual example of actual code. This is something that Guido always likes to point out, and you're gonna see why in a minute. Yeah, I'm sorry, I saw the poll on Vim and Emacs, like, this is neither. Yeah, like, I was a Vim person for a while, but I moved on, and you should too. Yeah, so this is, the greatest common denominator code, right? Like, easy math, right? Like, we have good education in Europe, right? Like, you understand what it does, good. So this code is awesome, it does what we want. But if we actually mistaken, the API and somehow gave it a string instead, then a type checker could tell you, hey dude, like, argument 1 to your function is a string, but it should be an integer, right? And you're like, big deal, right? It will crash in production anyway, and I would know. So this is not really winning anything. Well, yes, like, you're technically right, but the type error actually says, hey, your argument should be an int, and you gave it a string. And the runtime error says, not all arguments converted during string formatting. Thank you, Python. Like, now I don't know, like, what? So this is why type errors sort of are easier to understand to people, statically analyzed next to your code and not while execution, because Python is so dynamic that the error that you're actually causing by having a wrong type might happen very far from where you made the mistake. So this is sort of an example where we show, hey, this is actually cool, right? But these were just simple functions. How does it look like for classes? Where classes, exactly the same sort of thing as the extension of a type, like, fields or attributes. So again, if you do something wrong, like, it will tell you, like, hey, dude, like, the point thing there, like, that class doesn't have an attribute z. What are you doing? Or, like, you can check that actually it infers arguments just fine. Like, you put the integers in the constructor, so it knows that the fields have to be integers as well because they were just assigned. Reveal type is a special thing in MyPy. We're going to talk about this later. But essentially, this is what I wanted to show you, right? The thing is, we can use typing information to do type checking, and the errors that we're getting that way are much cleaner than runtime errors that can happen later. But types are not just like classes and the built-ins, right? There's more possibilities to what you want to express, obviously, right? So there's like multiple things, like, yes, I'm just gonna count to 3. I need you to all read this. No, I'm kidding. We're gonna go through all of these now, one by one. So first of all, like, some functions are really super dynamic. It's like, I am literally just accepting anything and I'm gonna be fine. So you can say this. You can say in typing that, hey, I already accept anything and I'm gonna be fine. Or I'm returning anything because that really is so super dynamic on, like, dispatch at runtime or whatnot. As you can see, we did something magical. We imported any from typing. So for all the things that are not built in Python itself yet, like, we just shoved them into the typing module. That includes a bunch of things that we're gonna see like in the next slides. But any is like the first, right? Like, if something is very super dynamic, we say it's any, right? So you shouldn't abuse it because it hides errors then. Then the type checker is gonna say, hey, anything is fine, so I'm just gonna assume you're right. Like, most of the time you're not, right? If you think about this, like, it's never true that it's any type that is true. It's like some of the types are gonna work, right? But you just don't wanna enumerate them because there might be 30. But still, like, sometimes it's actually very useful to use this functionality. So, like, I just start with this because people ask me, like, what if something is really not typable that easily? And a value with the any type is dynamically typed, right? So you actually need to understand this, that, like, it's different from just saying it's object. because it's essentially on the both sides of your hierarchy, right? That basically any is super dynamic. Right, let's move on. You could just say list, right? The built-in list as an argument to a function, but that doesn't say what type of arguments that list contains. Unfortunately, we cannot encode this information using the built-in, and we weren't ready to actually like modify the runtime aggressively before we proved that typing is any good. So there are generic variants of collections that you can find in the typing module. List is the first one, but there's all sorts of others, you know, like dicts and sets are the concrete ones, but there's also a bunch of abstract ones, right? Like, you know, you can have context managers and mutable mappings and, you know, iterables or whatnot. So you simply use the list, uppercase list from typing, and you need to use the square brackets for it. If you think this is totally terrible, like, yeah, like some other languages use, you know, like triangle brackets. The problem is like that would complicate our parsers just so bad, and the square brackets just worked automatically. So just, you know, you'll get used to it. Just trust me, it's not a big deal. If a function can actually accept a thing, but can also accept none, you can say it. It is pretty verbose at this point, and we're like fiddling with like maybe there's going to be a way for us to just use something less verbose. But it's almost like a good thing, because you should never make everything optional, because then you have to handle the two code bases, like, you know, like what happens if I get the string, and what happens if I get the non-type now. So this is how you can encode this. Again, don't abuse this when you don't need to, but if you're actually typing existing code bases, there's gonna be a ton of those, yeah, for sure. This is how you do this. Yeah. Historically, we also supported this notion that where a function already contains a non-default value, we're like, yeah, it's optional, right? Because you said it's a string, but you assigned none to it, so I guess they're like the type and the none is right next to each other, so like I assume that you wanted to do this. In practice, we found out that in fact, in code bases, like people really didn't mean to do this sometimes, so we're looking at just removing this from typing now, like from the PEP. So far, like you can maybe still see some libraries that are using this sort of syntax. Again, this was a mistake because explicit is better than implicit, right? So yeah, just showing this for completion. If something is not just like string or none, but like string or actually any other type, you can form unions. You can say, hey, I really want type A or type B because both are gonna be fine. This is not as easy as it looks. We're going to talk about this in the gotchas section. But you can do this. This is very common for Python, which is super dynamically typed, and it's duck typed, so you can accept like all sorts of nice things, right? If a function returns a value of the same type as passed as an argument, but there can be many of them, you can use type variables, basically saying, well, it can be pretty much anything, but if I take it, I'm returning it back. Right? This is like useful for, I don't know, like functions that transform strings, but also transform bytes, right? And like all sorts of other stuff, right? Like for example, like the S argument here could be essentially a self as a method. So we're saying, hey, like I'm just gonna keep returning the same thing, like myself, right, from that method, right? So specifically, if you want to make this work for like collections, you can also do that, and that like actually works pretty well. So you can say, hey, I'm accepting not one string, for example, like this T thing, but a collection of them, and I'm just gonna return one. Like if you would look for stuff and wanted to return the first, right? I don't know, or like the biggest one or whatever else. Like this is how you encode this information that like, yes, I'm just gonna look at a list of things and return one of those things, or maybe a new one, but like this is gonna be the same type, right? Specifically, there's something that like sometimes is useful where like, yeah, it's an int, but I don't mean any int. I mean like, I don't know, like an FB ID, which is like on Facebook, like everybody has an ID, and like every piece of content has an ID, and like those IDs are pretty global. They're like all over our database. This is how we shard things, whatnot. So if you wanted to use like FB ID specifically, and you want to say, not every int is fine, It's just when I encode it, only FB IDs are gonna be considered okay, and everything else, like, I just want to throw errors. This is how you do it, and then you just have to remember to always do FB IDs where you, like, you know it's an int, but no, it's not, it's an FB ID, right? Yeah, so if you actually accept classes and not objects, right, of a certain type as an argument, or maybe you're returning that, you can do it by basically saying, hey, I want a type of this thing, right? Because if you just say Django.model, it means like, oh yes, this is going to be some instance of this class. If you actually say, yeah, I want to have some class like this or any of its subtypes, right? Because that's the point of like this example, right? This is how you say it, right? So this would be some factory that takes any Django model and returns an instance of it. Nice. Yeah, so specifically, you can, again, like, do this in a dynamic way where you say anything that's you give me a class of, I'm going to return you an object of it. This is how you do it. Like, the confusing maybe thing is like that you have to bind the type variable basically by saying, it's a type variable, right? So, but it is actually not valid for anything. It's only valid for Django models and its subclasses, right? So this is how you're saying, yeah, I want to make this dynamic nice thing, but I really don't mean like a type of int that is going to return an int that's still going to be an error. So this is how you bind them. Let's talk about inference for a second. What do I mean? Well, it would be super tedious if we had to type everything, you know, manually and like all variables and everything. That would pretty much like defeat the purpose. And for Python, that would create an uprising and, you know, like squashing them, and it's like, you know, it's expensive. So why do this? Like, instead, we can actually use our static tools to like say, oh, I can see what you just did, right? You assigned, and I'm just going to assume this is always true. So pretty much like, if we have an assignment that is clear and unambiguous, type checkers can, and already do, use this information to just assume, oh, your variable is going to be 1, right? So it's an int, okay, good. Or it's going to be a list, and it already has elements, so I know it's a list of strings. That's amazing, right? If you then try to like reassign that value to a different type, like, you know, the type checker would complain, would say, hey, you said it's an int before, and now you're just assigning a string. Like, maybe just create a new variable. They're like almost free. Do it. Yeah, if the situation is different, right? You're creating a variable and you just don't have a good value for it yet, right? This is where you shove the nuns, or create an empty list and just assign values to them later. The type checker is like, yeah, it's an empty list, and then the guy adds strings to it, but what if it's also okay to add an int? Like, I cannot infer safely that like this is always going to be a list of string, because now the intent is not so clear. So in this case, you have to actually, like, you know, annotate your variables. You have to say that, well, I really mean a list of strings. In another case, like, the type checker would likely just tell you, hey, I really need you to explicitly say what you mean here. Yeah, so we need generics, right, for collections, but not only to just say, I accept this argument and I'm just going to check if all the guys inside are strings, but also like types very often have methods inside them that like are returning like elements from a collection, right? And knowing what the collection contains enables us to like make this mechanism like work really well. Like, if we pop something, we know that popped something is going to be always a string, because it is a list of strings. That's amazing. And then the entire program gets much more statically typed that you know expected, but you don't have to write much more. You just declare it as a list of strings once, and like everything else now is inferred. Specifically, we can even improve the inference by like saying, oh, this can be optional or whatever, but like if it is a none, then I'm just going to return early. So like the type checker is going to understand that, okay, so if I'm below that point in my function, is never going to be none because I would return already. So the inference is not like very primitive. By saying that, I mean like there are still things that we can improve in it, like for sure, but it's already smart enough for most of the cases to not be annoying. Like, you don't have to repeat yourself and like put the types all the time very laboriously. So inference is cool. I like it a lot. It makes our code like still pretty readable, but at the same time like safer, and we can check if we're doing what we want to do. So variable annotations help you with the non-obvious cases. Use Python 3.6. You have to already build it yourself, so just use the latest version. It's just there's no point in using whatever your operating system gives you. It's going to be outdated, and you're going to be sorry. Like in older Pythons, you had to use those like ugly comments, and frankly, like, I don't know, I don't like them because the other linters get confused by them, and it's very verbose, and it looks like a hack, right? It looks like we didn't think it through. So in fact we did, but originally we weren't really sure if like the typing thing gonna take off at all. So we didn't want to like modify the syntax just for that purpose further. But now at 3.6 time we already know like, hey, this actually worked out pretty well. So let's just like remove stuff like this. And the type comments, you can use them even on Python 2. But why would you use Python 2? All right, let's move on. When everything else fails, you can cast a type basically saying, yes, I know, it looks like I'm returning something else, but I really, really know that at runtime something super magical happens, and this is going to be fine, like, shut up, type checker. So you can cast types. But like, fortunately, like, if you saw this and you're like, oh my God, C++ now, right? Like, no, like, this is very rarely used, like, don't worry. But it's there, right? So I just want it to be complete. Like, like sometimes there's going to be some places in your code base where you're probably going to do this, but for 1 million lines of code, there's going to be like 4 places. So like, if you have more, like you're doing something really tricky. Gradual typing. I have 1 million lines of code. How do I start? The entire purpose of gradual typing was that in a statically typed language, you pretty much have to have all the typing information, otherwise the compiler is like, you're doing something wrong, I cannot create your program. Like in Python, we are like almost the opposite inside, because in a dynamically typed language, like the types are only like a way to structure your code. They're only like factories of objects. And when you're actually executing the code, like anything that just happens to have the right methods at the right time, it's just fine, right? It's just gonna run. Well, unless you do like runtime is instance checks, which are essentially just, like checking for the right attributes and failing if it doesn't work. So this is like instance checks are bad for performance, and they cloud your business logic. So those wouldn't be the solution for gradual typing, right? With gradual typing, we pretty much want to have this, right? You have like your code base, and you run the type checker, and it says, nah, I don't know, maybe it's fine. So you introduce your typing information function by function. You increase the coverage, and as you do this, like you are increasingly sure that your code is actually fine, right? Like, oh, I don't have type errors, I'm so good. So it reveals bugs one by one, but the thing is, we want to make it gradual so that you don't run the type checker and suddenly get like 7,000 errors on day one, because this is just saying, oh my God, I should just open a bakery, right? And in fact, this is what we're doing. Like, this is Instagram. Like, the data doesn't go very far in the past because we are stupid and we started metrics too late. By saying we, I mean I. But now we're okay, right? As you can see, like, this journey is like 15% done at this point. Like, this is the number of functions with full annotations. Yeah, like as a metric, use functions. Like, any other thing just doesn't make any sense. Like, just to show you a comparison, like by lines of code, like we're below like 12%. Is like, I know 11.5. I don't know what it is. But lines of code doesn't really tell you much, especially that there's gonna be like a bunch of totally old functions that have like 500 lines or more, and like good luck typing those. Is going to be tragic, and you need to refactor first. But yeah, like function-wise, 15% there. So how do you get there? Well, first of all, you have nothing, right? Like the type checker at this point pretty much just shouldn't like generate any errors for you. Like that's not entirely true because of globals and whatnot, but just like think functions, right? So like in terms of functions, it should be like, okay, fine, like nothing has annotations, so the type checker ignores it. It assumes that a function that is not annotated has all the types in the signature set to any, and I'm not even bothering to like look at its body then, right? Like it's any. It's just everything is any, and the body is like whatever. I'm just gonna be quicker about my checking and just ignore the entire function, right? So when we type the first function, the type checker will be able to find some errors, but they're going to be like very few errors because it's going to only look at that function's body, and maybe it's going to already use some like built-in types and the standard library, and it's going to find some error there. But pretty much this is still like not very comprehensive. You just started your first function, you're happy because there is a type annotation now in your code base committed. This is amazing. But by doing this, by annotating that first function, we already created a bunch of functions that are using our first annotated function. And if we then annotate those, we will be able to not only check against the standard library and built-in types, but also against the usage of our function that we just annotated, which is nice, right? So when we then go and annotate those guys, we'll find out that, oh, actually, in a few cases, we were using our function wrong, right? So you can actually find more bugs, and the more you do this, the more you keep at it, like the more the type checker gets useful, right? So at first, you're gonna, actually put some effort to set up the type checker, and you're not gonna really see much like win, right, from day 1. But like from day 10 or then 100, like you're gonna be amazed how you ever worked without it, because it's pretty much like now it finds all sorts of problems where, oh, this can be actually none, but we never checked, right, and stuff like this. But it really means you have to start like annotating in this sort of smart order so that you actually utilize the information of the functions that you already typed, right? Let me give you an example. Is that readable at all? I guess the spotlights and everything make it a little less readable. The thing here is, right, we have 3 functions, and they're not annotated at all. So the type checker is like 0 errors, 0 warnings. I am happy, right? But if you annotate just the first one, the process input one, the type checker is going to be like, dude, like sort, the method doesn't really return anything. So, apply yourself. You weren't paying attention. And now I'm like, oh, fine, yeah, okay. Yes, this is true. But look, all the usages of that function elsewhere don't actually raise any errors yet, because those other functions aren't annotated yet, right? So let's annotate another one, right? And if we annotate the process all function, we just annotated in a sort of wrong order here, we didn't get any new information. Even though, if you really look closely, like the process strings usage on line 4 is totally wrong. Like, the guy just didn't wrap like the list in an actual list. That didn't specify the repeats number. Like, but this error is not shown, it's not generated, because the type checker ignored the process strings function, because the process strings function is not typed yet. But when we finally get to there, we're saying, oh, now we find no issues in process strings. Look, see, like process strings is fine, but by annotating process strings, we unveiled errors elsewhere, right? And now process all actually has like a good bunch of errors, like 3 errors are just that one function alone, right? You see that the arguments are all wrong, and the return value was expected, but we said that we're returning none, and we're not. Liars, right? So like this is how this works, right? The more gradually you're typing your code base, the better it gets, right? It gets covered, and it can unveil errors also in stuff that you didn't touch, right? Because suddenly all the users that are also typed are going to be checking against the annotation that you just put. So to reiterate, right? Like before we type the first function, the type checker doesn't really know much. Like even like if you get some like errors about globals or whatnot, this is like typically like it doesn't say anything. When we type the first function, the type checker will be able to identify very few errors, and then we annotate more functions, right? And by doing this, we will find errors in usage, right? This is what I'm just showing you as an example, but what I actually did was a bit different, right? Because what I did is we didn't really quite well annotate the function that we wanted first that was used elsewhere. So the first round was actually everything is fine. We felt so great. Everything is green, right? Like, we typed so many functions, and like we were actually not so bad programmers after all. Like, we can go and have a beer now. And then we annotate this special function and identify that actually we weren't so great all along. So that's the point, right? Like you have to identify the right order to actually see like the biggest win for you. And that wrong order here it's like eventually you're gonna converge to the same result, right? But that order is a bit more confusing because then you suddenly unveil problems in code that you didn't yet touch. And like, the human brain works like this, like suddenly you get errors like in other files, like that somebody else put in there like a few months ago. And it's a bit discouraging. You're saying, well, I'm not sure if I want to fix those things now because like this is some like other library code that, like I don't care about that team at work, they're assholes, right? Like, yeah, so like the right order is key. So find most critical functions, start with those. If you do that, like then you sort of minimize type checking errors that appear in untouched code, right? So that would be my first piece of advice. Second one would be, you can very easily enable a file level linter, that people are going to use at your company, like, I don't know, either in your code review tool or in your, editors, even in Vim and even in Emacs. I know I'm judging, right? Yeah, so anyhow, like for this, I would either use PyCharm or Flake8 MyPy. Like, there's like no configuration needed, just use that and it's cool, it's gonna do the correct thing. So the way the coverage goes up steadily is like, people just get value early, they just annotated their function and had like some wrong usage of the standard library and they already see it, right? So this is a very easy way to like get the ball rolling. As you can see, like it goes a bit counter to my first point, which is identify the right functions. Don't let people just like randomly type code now, right? But in practice, it's like, amazingly, this is not a problem. And the reason is that usually this involves people creating new functions, so they don't really have any usage yet, right? And by covering core dependencies earlier, right, you did that point one first, it's likely that those people now are actually going to use those core functions that you already typed. So like in practice, it's not as terrible as it sounds like to just like let everybody play with type hints now that they've never seen before, right? It's actually pretty cool. But what did I mean, file level? Like this is like a new thing, like, like people don't talk that way. Like, is that a word? So yeah, if we want, you can import a thing, right? Because it would be very tedious to just put your entire code base in one file. So we have a ton of files. Some of them are ours, some of them aren't. But the point is, like, you're gonna import a lot of things, right? And to know now if we have any type errors in our program, we have to actually look through all the imports and the imports of the imports and just, pretty much do a full program analysis to get to like the entire situation and be able to say, oh, this is actually fine. It looked very crazy, but at the end, like, something happens 5 modules later and yeah, okay, everything is okay. Or the opposite, right? We are actually gonna say that, it looked fine, but like the 5 modules later, this is actually sometimes returning none, and you are not ever checking that later. So you have to do full program analysis. MyPy is a project started like in 2013, I think. Like in full speed, developed by a bunch of Dropboxers in the Bay Area, and in London, Yuka, the original author, is in London, I think. So yeah, this performs full program analysis. You can just download it, read. It's actually pretty good documentation and start using it for like seeing your entire program. How is it doing? There's a few problems with this. So like, first of all, like this makes it very slow now. Like if you have a big code base, like on Instagram, it takes like 4.5 minutes like to just get through the entire code base. So you can use it as like a unit test or something that is happening during code review, like almost like a build to check. But you cannot use it as a linter, that just wouldn't work. You cannot have it in your editor, right? Like obviously. So if MyPy cannot find an import for any reason, like it's just some like magic Python home thing, or it's some like pretty dynamic thing that is actually happening. It just assumes that, okay, I'm just gonna say that all of those things coming from that import are any and it's all fine, right? So I actually use this to just create Flake8 MyPy that is using MyPy, but only just shutting down this entire full program analysis and only looking at your particular file. And the standard library as well, like, that's something that we can also cheaply do. And this is actually pretty fast, like that takes like typically like under 1 second. Like, so if your editor isn't dumb enough to like do linting like in a synchronous way when you save, but it does it like sort of in the background, you're never gonna know. It's just, sometimes the error appears like a few seconds later than you actually put the line in, but that's still right there in your face when you're developing, which is exactly important for linting, right? So this is why you have like file level and you can have the full program analysis that so far it's pretty slow yet. Yeah, so what about the situation where you're like, okay, I'm typing my functions, I'm so cool now, but I'm using, I don't know, click, flask, requests, or whatnot. Like, what about those things? I don't own them. I cannot tell Kenneth Rice, like, you know, hey, dude, like, type your stuff. Actually, I did, and I think they're going to go with it, but so far they didn't. So what do I do then, right? If you have like a bunch of functions that you're using that are not yours, you can cheat, and you can use the so-called PYI file, which is almost like a header for Python files. People also call them stub files. How does one look like? PYI files are essentially Python files where you write all the classes and methods, but and functions, but you don't put the bodies in because it's not code. It's a definition of like, this is how the module looks like, and this is the functions that it has. So you do this. It's nice, and then the type checker can use this information. So for third-party code that is not yours, this is great. But this is even better for situations where like I am using Python. I am using some other like magic way of writing C extensions, and they are just SO files. There's no Python file, so the type checker would not be able to tell you anything about this code. Well, fortunately now you can write a PYI file and cover those files as well. And in fact, this is what we do for the standard library, for the C extensions in the standard library, and to sort of type annotate the internet. The project is called TypeShed. It's on GitHub, like pypy/typeshed. And it's already used by PyCharm. It's already used by MyPy. So pretty much like the nice thing about it is like it's a shared collection of typing information that various tools are using at this point. So if you wanted to add another library to it that is pretty popular, you can do it there, and then like all the tools are gonna be able to use it. But when you do, and you already run this very slow MyPy that is very useful because it tells you all the very tricky problems across files, you need to set it up as continuous integration somewhere, because if you don't, you'd be amazed how fast people make changes that break typing, and then you run your tool like 2 days later and you see, oh, somebody just added something that broke this and there's an error, but they never knew. So set up continuous integration early. This enables full MyPy checks. Otherwise, they are too slow, but then continuous integration is just like a, I don't know, continuous build. Most people are just waiting for the green, you know, anyway, doing something else, so that's fine. But also have a command that people can run locally that does exactly the same thing, has the exact same setup, has the exact same MyPy configuration. Because if they are actually informed by continuous integration that, hey, you did something wrong, there's an error, the first intuition is going to be not like fix it, but just like, hey, can I even repro? Like, I don't trust this tool, so they're going to want to do this locally. And if you say, no, don't, like, just like fix it and just re-upload, they're going to be like, no, I'm just not going to do it, your tool sucks. So have something that they can also run locally. That actually helps a lot. So just to reiterate, right, like only annotated functions are actually type checked. Everything else, just assume it's any, I don't care, I'm already slow enough, I'm just gonna ignore this function. A clean run of the type checker doesn't say that everything is fine, right? There can be very many errors still hiding there. But if there's an error, you can pretty much be sure that the error is there. That's the point of type checking. We are pretty strict about not raising false positives. This is not an opinionated pylint that says, and on a scale of 1 to 10, your code is -half, right? Like, you know, no, it's actually something that tells you errors where you make errors. New annotations can discover errors in other functions that can be in different files that could be pretty old and it was wrong all along. So just, you know, you have to realize that this is going to be the case. Flaking MyPy only checks stuff that is in your file, but it's fast enough to do, like, you know, checks when you code. And PyCharm does like a very similar thing, and you can even like click through between files. So like, you know, I don't think I need to sell you on PyCharm, use it. Yeah, full code-based checks with MyPy, use them, but as continuous integration. And all of this is like, okay, I'm just gonna do it. It's gonna be amazing. I'm just gonna be so popular in my company. Everybody's gonna congratulate me. But like, for what exactly, right? It's how do I measure that we won? Like you know, like where's my medal? Like, you know, how do I get it? So first of all, like you saw my nice graph, right? The reason we set them up is like we wanted to actually see how we're doing, like how many functions are there, like that we actually annotated. Especially on the graph, maybe you notice that sometimes the coverage would actually fall down. So like nobody would remove annotations, but the point is when developing new features, there would be people that didn't know about annotations yet and they wouldn't add them. So we were sort of racing with people adding new functionality and us actually annotating existing ones. So set up metrics early. And also you can set up metrics for the number of type errors and attribute errors that actually happen in production. That way you can sort of see the correlation, like are we typing something that is useful, or are we just doing some academic like exercise? Like, you know, full disclosure, so far for Instagram, it looks like we are mostly doing academic exercise because the correlation is very hard to see. And this is something that I like, if you have ideas, like come to me like later, because it seems like the change in the code base and the change in like user behavior and whatnot makes just the type error, attribute error like metric pretty noisy. We are seeing that it is like, yeah, like situation is improving, but like it's not super like clearly correlated to us covering the types, right? So we actually think that we're probably just making developer efficiency better so that they don't introduce more bugs before they actually release a feature to production. But for removing existing ones, well, it's not so clear-cut. But if you do this and you discover this magic way where it actually worked for you, write a blog post. It's going to be on Hacker News because people are actually big on this thing now. So we're almost done. Now it's the section where like you're all going to be confused and you're going to say this typing things like, no, like, how about we don't use it? So first of all, remember, only annotated functions are typed. If you don't annotate a function, you can still use reveal type from MyPy. You can still like look inside and sort of try to infer things. But it's going to be very confusing to you because it's going to say, yeah, A is any. And you're like, how is it any? I typed GCD, like it has a return value right there. Well, but you didn't type function F. So MyPy doesn't give a damn about this. So yes, only annotated functions are typed. Another example of this is this, like, you know, you try to convert something to string, right? Like you convert to upper, whatever, and there's not going to be an error because convert to string is not typed. But at runtime, there's actually going to be like, you know, crazy stuff happening. So yeah, like this is gradual typing. Like you cannot eat the cake and have it too. So like we didn't want to like pretty much discover a new language and make it all strictly typed, but this is going to be sometimes confusing to you. You're going to be like willingly putting types in, and the type checker is going to be telling you something that is confusing. Like really just check if you type the right function, because very often this is the case, which is why I put this gotcha first, because that was confusing us at first a lot. Unions. People often think like unions are awesome, right? Because you can say, I want an int and a string and maybe a list of strings and it's going to be all cool. But in fact, they don't do what you think. They don't mean that now it's good to do more things with your function. In fact, less things are safe to do. What does that mean? Well, if you only take a string as your argument, that means you can run upper on it, you can run lower on it, you can do like a whole bunch of things that are actually totally sensible for strings. But if you take a string or a list of strings, then well, you have to have a check in your code that like, oh, if this is a string, then do this. If this is a list of strings, then do this other thing. So it actually limits how you can use the argument safely without a type checker error. And the type checker is going to be very, very strict about telling you this all the time. Like, yes, it was cool when it lasted, but like now you're accepting lists too, so you need to check first that it is a string. Even in production, it just never happens to fail because people just never use this API like this, right? But this is what the type checker needs to do. Like it is like sort of your mom. It will tell you the same piece of advice every time, right? You know, all along. So unions limit what the allowed behavior is. And the thing about this is that if you design a function, you write a new function, and you say, I can either return a none, or I can either return this type. So people very often say, oh, I know, I'm just going to write that I'm returning a union. That's clear, that's like intent is there, it's explicit better than implicit. Like Guido would be proud of me. And Guido would say, just write any. And you're like, Guido, you were my, you know, mentor here, like, and you're saying any. Like, no, but Guido is saying, don't annoy your users, right? And if you create a new function, and it's suddenly a union of 3 types, anytime a person actually has to use your function, they will have to do this. If this is a type of this, else this is a type of this. This becomes a tedious thing to return, to actually use. Like, so your function is going to raise errors just on the basis of people not doing edge cases. And you would think, wait a minute, this is exactly what the type checker is supposed to do. Well, but if that second type is super unlikely to ever happen, because it only happens if, I don't know, like your like environment is set up in a very special way, or if you're running on Windows, but you know your production is never going to be running on Windows unless you buy some VR company, then you do, and then you're pretty much, yeah, like stuff happens. But like normally, like you can pretty much see when there should be a union, but that very special case is actually so very special that it doesn't make sense for us to like inconvenience ourselves day to day. Well, in this case, consider just returning either any or just saying that this very likely type is what I'm returning, not anything else. Yeah, so that pretty much shows what I just talked about, which is that, you know, you need to then do the checks of like, oh, like this is either a string or either an int, because otherwise it's unsafe, right, to just assume. Let's go through this a bit quicker because I don't have much time left. Out of order definitions, that happens often, that happens all the time, right? Python files are very primitive. They read from top to bottom. This is how you actually import your code. But inevitably, you're going to find something where I have 2 classes, and in the class that is above, I'm returning an instance of the class that wasn't there yet. Well, guess what? Function annotations are being evaluated on import time, so that type doesn't exist yet. And in this case, if you didn't put it in strings, Python would just fail to import your code, which is pretty sucky for something that is used for static analysis and not on runtime, right? So yeah, like admittedly, this is not very elegant, but so far we have to use this. So you have to use like the strings and whatnot. But it gets better, right? Because we are annotating existing applications. So you're like, oh, I need to like take this one type from somewhere else. I know, I'm just going to import it, and then you get a import cycle, and like everything is terrible, and you're re-evaluating your life choices. Maybe that bakery wasn't such a bad idea. Like, so typing actually has this thing where you can import a special control variable, and it just says if type checking, then like import this thing, and you type it all in strings. You have to do it in strings because, again, this is the same thing. In production, the type is not going to be there because you don't import, because it could be a cycle. So you have to use the string, because otherwise, yeah, like it would be a name error when you're importing. Better yet, and this is like, this just makes me like, you know, like angry. You have to put no QA if you're using flake8, because now this import is not used, right? Like, yes, import cycles are not great. Like, this is how you do this. I'm sorry. Mutable collections are invariant. You understand some of those words, right? Like, this was me too. Like, you know, I was like implementing this, and like, yeah, like, no, I don't understand this. What does this mean? Well, these 2 functions look sensible, right? It's like, oh, if I have a function that takes a list of optional strings, so there can be either strings or nones, and I have another function that uses the first one, everything should be fine, right? Well, it's not. This is actually a problem. There's a bug there. And MyPy is going to tell you that the list and list of optionals are not compatible for this use case. And you're like, what the hell, MyPy? Like, they are. Well, if you think about this, the collections here are mutable, which means the function f can at any point append new members to the list L, right? It's perfectly valid for the contract of the function f, because this is what we said, that we just accept a list of optional strings, so maybe we were also going to mutate it. And then function g might end up having a none, in something that it considers in its own contract to only be a list of strings. Uh-oh. So like that would be probably a problem. We would have bugs in production that the type checker failed to find. So it does find it. It just will tell you, hey, in this case, you just cannot do this. So how do you solve this, right? In this case, you're like, I don't know what to do. Well, you can pretty much one of those, or maybe all of those, you can change to be immutable type annotations. In which case you're saying, yes, I know it's a list of optionals and it can be either none on a string, but I'm not doing anything with it. For me, it's just a sequence. I'm not touching it. I'm just reading from it, right? In which case it's like, oh, okay, fine. Then they're compatible now. It's only about the fact that if you mutate a thing inside a function, then you can actually influence its type. And this is why you have this error. These are all the gotchas. Like you can now like breathe again. Like it's not all terrible. It's simply like there's a few things. This is something I get often. Like, hey, can we do all of those crazy things later? You know, like it's gonna be so awesome. And in fact, like all those things. Like I wrote those slides like 7 months ago for an internal talk originally, and then just kept expanding on it. And then they were like all crazy ideas. And now we almost do all of them. So it's like. Wow, like you should never assume, right? Like you should never make assumptions. Like, you know, the internal video of me saying that this will never happen, like, you know, like I need to delete it, right? Like it needs to disappear because like people are like, this guy, you know, whatever. So static type inference, like at first we were looking at like, how about we actually get types from existing code base and just like have them presented to the user, like just annotate like next, finish, and you have all types. Well, pretty quickly we found out that like this is very tricky because you have like central code base somewhere which like does something very crazy dynamic, and then you say everything is any because it can be like unions of 20 elements all the time. And also it's difficult to implement, so I was like, I would never do this. And then people came and did it, and it's actually pretty useful now. Like there's a Google project PyType that does this for their code base. And also there's like some internal tooling that we have for this that I hope will open source, like that actually does this pretty well. So static type inference turns out it's not such a crazy idea. How about we do this from runtime? We actually gather information about types that we actually see in production and then just suggest like, hey, this is only ever an int, that should be safe to type, and like stuff like this. So it like, for me it sounded almost like, yeah, but these types are different because like you're not gonna ever annotate anything as a iterable because there's like always lists. And then like what if actually this is a dynamic function, and again you get like a union of 20 types. Like so like this is a stupid idea, let's not do it. And then somebody did it. And it turns out that it's super useful. Most of the time people like are using their functions in a very simple way. So you cannot type everything, but you can type like tens of % of your code base that way. And this is in fact the biggest jumps that you saw on the graph of Instagram were like usages of this tool, where like we're just recording types from runtime and just applying them because they are literally doing what we wanted. And that pretty much is still manual work, but it's like twice as fast. So again, I hope we're gonna open source this soon. Runtime type checking. Well, annotations are preserved at runtime, so you can just like do like magic decorators that do this. Yeah, so I'm not super like keen on this idea because I'm like, oh yeah, like we could do this at unit tests, but during unit tests you're also mocking, so you'd be, you know, crashing for type errors that are not, because you're literally changing something to some mocked version. And it's fine if you just use the mock library, but what if you're creating like custom mocks? How would you like set those up? So now this is a stupid idea, but turns out there's already PyPI packages that try to do this. So I guess like somebody will come up with a very good program to do this and like write a blog post, like, and it's gonna be a thing in a few months. So yeah, like I'm actually pretty excited to like see it working. Yeah. And then duck typing, like people are like, dude, now you're telling me it's a list of string, but it's anything that I can iterate on. Like, what are you doing, right? Like, it's duck typing, right? Ducks, man. Like, yes, fine, yes, we get it. Like, you know. So now actually, like Ivan is writing a PEP that for some reason he also added me to co-authors of, which is called Protocols, and it's doing exactly this. It's saying any type that is whatever, but it just contains those fields and those methods. It's fine, right? So I think this is gonna help with the biggest gripe that people have about typing now. So this I'm like super excited about. And finally, like hey, if we already know the types, can we make it go faster? The types are different. They're like iterables and sometimes unions and sometimes other things. So they're not essentially specializations. So again, I was like always telling people like they are different. We're not going to do like performance optimizations. And then the Python people just looked at me and they just like kept looking at me and like, no, you can. So yeah, like we are actually looking into like using this MyPy's inference to like do ahead of time compilation now, and apparently Yuka is like already having a prototype where it does something useful. So yeah, like all those crazy ideas, not so crazy after all. Like this is actually gonna get us very far. Where to get support? MyPy docs. Read them. If they're wrong, you can also open a pull request. It's all open source and they're actually pretty cool. They are meant for people like you, so if they fail, let's improve them. If anything doesn't work as you expect, Gitter, which is this like magic Slack-like whatever thing that just integrates with GitHub, has a typing channel where you can ask questions. This is actually very useful. Like I use it pretty often. And then Python/typing is where the work on the actual PEP 484 is. There's still open issues there. You can open another one if you like, you know, like it's not like it's super complete at this point. It's a work in progress still. MyPy is the type checker that does like all of those like crazy things to look at the entire program. Obviously, it's going to have a ton of errors still, a ton of like problems that like stem from the fact that it's pretty young, which is why it's not shipped with Python yet. But you can use this. And finally, typeshed is where we put all the type annotation for the internet. So if you want to contribute something, feel free. We're pretty fast about accepting new contributions and fixes for existing types. So this is it. I'm only 30, 31, 32 seconds over time, so I'm pretty happy with this. Thank you very much. I will be taking questions afterwards.